everyone, welcome to homework 5.10. I have really bad allergies, so I apologize if there's lots of throat clearing, coughing, and pausing in this video. I'm going to do the best that I can. So the first one is solve each equation and write the solutions using plus minus notation. You all have been doing this for weeks now, okay? So we're going to take the square root of both sides, and that means x equals plus or minus the square root of 144 is 12. And again, if you don't quite have your square roots memorized, start to get those memorized. Taking the square root of both sides, we get x equals plus or minus. 5 does not have a perfect square, so this would be the square root of 5. And you can use your calculator to solve and get, close to an approximation of the square root of 5, and then write that next to it. You can also estimate the 5 is going to be between the square root of 4 and the square root of 9, so it would be 2 point something. On the low end of the 2 point something is what you should get when you use your calculator. Now for this one, before I can take the square root, I'm going to go ahead and divide both sides by 2, because then I will get, sorry, not by 2, by 4, excuse me, by 4, we'll get x squared equals 7. Now I can take the square root of both sides, and we'll get x equals plus or minus the square root of 7. Again, you can estimate, use your calculator to the nearest hundredth. Remember, plus or minus. Here, square root of both sides, x equals plus or minus. With fractions, you can take the square root of the numerator and then the square root of the denominator. So the square root of 25 is 5. The square root of 4 is 2. That's it. You're writing as a fraction. All done. For letter E, let's divide both sides by 2 first. We get x squared equals 11. Not a perfect square. Take the square root of both sides. It's plus or minus the square root of 11, which again, you can use your calculator to estimate. This one, I'm going to take the square root of both sides, I'm going to divide by 7 first. So I get x squared equals 16 over 7. And take the square root of both sides here. I get x equals plus or minus. Now this one's interesting because the numerator has a perfect square, but the denominator doesn't. So I can actually write this as 4 over the square root of 7, or you can leave it as the square root of 16 over 7. Either way, you will get the same answer. All right, part 2, match each expression to an equivalent expression. So we want to match up from the left to the right. So 4 plus 1 is 5, or 4 minus 1 is 3. So A matches with D here. The square root of 4 is 2, so this is 10 plus 2 or 10 minus 2, which is either 12 or 8. You can see that here with C. Negative 6 plus 11 is 5, or negative 6 minus 11 is negative 17. So that matches nicely with A. 4 plus or minus the square root of 10 is 4 plus or minus the square root of 10. That one's pretty obvious. And then the square root of 16 is 4, and then plus or minus the square root of 2 is here. Technically, this could be plus or minus 4 as well. All right, A says, is the square root of 4 a positive or negative number? Explain your reasoning. Well, it could be either. It can be negative 2 or positive 2 because a negative times a negative gives us a positive. All right, so they're going to give us the same explanations for these two here. What are the differences and why do these have both a positive and negative answer for them? Okay. Number 4 says technology required, so you need your calculator for this, or if you're at home and you can use Desmos. For each equation, find the exact solutions by completing the square and the approximate solutions by graphing. Then verify that the solutions found using the two methods are close. So we're going to complete the square, and then we're going to look on our graph to see if that's accurate. So I'm going to process through the first one, and then I'm going to have you do the second one on your own using my model from the first one. So subtract 8 on both sides. I'm just moving that constant out of the way. That's the only reason why. X squared plus 10x equals negative 8. This gives me space here so I can complete the square. So I'm going to take half of 10, which is 5, and I'm going to square it, which is 25. So I'm adding 25 to both sides. This side now is a perfect square. This is x plus 5 squared equals -8 and 25 is 17. Now, as you can see, the left side is a perfect square, but the right side is not. So when I take the perfect or the square root here, I'll get x plus 5 equals plus or minus the square root of 17. And then if I subtract 5 from both sides, I'll get x equals -5 plus or minus the square root of 17. And so then we can calculate that to see what that would be. Well, looking at that, it's going to be plus or minus 4 point something approximately, because 17 is really close to 16. And so this would be probably um, like a -0.9 maybe, -0.8, and then it's going to be a -9 would be the other one. So let's take a look at our calculator and see what we get. 10 and 8. Okay, let me make sure I have that equation. Good to go. All right, so, whoops, I moved away from the calculator. All right, so y equals x squared plus 10x plus 8. Is that correct? Is that the right equation? Let's see. That is the correct equation, so let's go ahead and graph it. And then we can see we have 2 points here. So, second, calc, 0. I'm going to go to left here. Remember I said about -0.8, -0.9, and looks like -0.87. So it's pretty close. -8, we would round that up a little bit. So -0.88. And then the other one, let's calculate the other 0 here. To the left, and then to the right. And guess. Oh, oh, ah. All right, graph. What's going on here? I think I didn't do that very well, so let's try it again. All right. To the left, enter. To the right, enter. Guess. Yes, there we go. Okay, so -9.12, right? So looking back at our So looking back here, we can confirm that that is pretty close and that our answers are accurate. So you're going to do the same thing with this one over here. Complete the square, see what you get, estimate, right? And then go look at your graph and see if you're close to the same values there. Number 5, Jada is working on solving a quadratic equation as shown here. She thinks that her solution is correct because substituting 5 for p in the original expression, p squared minus 5p gives us 5 squared minus 25, which is 25 minus 25, or 0. Explain the mistake that Jada made and show the correct solutions. So here, the reason that Jada is not quite correct is because she needed to set both of her factors equal to 0. So she should have 2 solutions because 0 squared minus 5 times 0 is also 0. And so she should have 2 solutions because she only solved for one factor, p minus 5, and not for p. So that's important. There should be 2 solutions in this case. Number 6, which expression in factored form is equivalent to this? So one thing that we can do is look at the end term and see what we have there. And I see that all of these multiply to be 5. So the next thing I'm going to look at is the middle term, because it looks like all of these will also equal 30. But I want my middle term to be 31. So if I do this one, I get 30x squared plus 25x plus 6x plus 5. So this one looks pretty good. Let's see about the next one. Here we get 30x squared plus 30x plus 5x. So this is too big because that gives me 35x. Let's try this one. We get 30x squared plus 15x plus 10x. That's going to give me 25x. So not quite big enough in this case. And then this one is going to give me 30x squared plus 30x plus 5x. So similar to the second one, it ends up being with a linear term that's not quite right. All right, so A is in fact our best answer. Number 7 is a kind of review from a while ago where we have two rocks. The height of rock A is given by function f. The height of rock B is given by g. In both function, t is measured in seconds after the rocks are launched, and height is measured in feet above the ground. Which rock is launched from a higher point? Well, notice these equations are written kind of backwards from the standard form, starting with a constant. So in this case, it's rock B. Our constant is 5. Which rock is launched with greater velocity? Well, this would be rock A because our linear term is 30, so that would mean it's being a velocity of 30 feet per second. All right. Number 8 is a review of absolute value. So it says describe how the graph of f of x equals the absolute value of x has to be shifted to match the given graph. So in this given graph, our vertex is 4, 0. It's a positive 4, and it's not going up or down from the x-axis. So this means the only shift will be inside of our modulus bars. And so this will be x minus 4. Now remember, a good way to check this is if I were to plug in positive 4, 4 minus 4 does in fact give me 0. So that's a good way to check to make sure you went the right direction. In this case, we're going to the right, and so inside the parentheses will be minus 4. Write a function for the oh, we did this. So this is the equation. All right, you could also write it as y equals x minus 4, but since it says function, function form would be better. Number 9, for each equation, identify the values of a, b, and c that you would substitute into the quadratic formula to solve the equation. So all you're doing here is saying a equals 3, b equals 8, c equals 4. A equals 2, b equals negative 5, c equals 2. All right? So you do that for the rest of them. You can do this 100% on your own. You're just labeling A, B, C for each of them. A, B, C. A, B, C. Tell me what they are. Number 4, suddenly number 4. Sorry about that. 10 maybe? Use the quadratic formula. So quadratic formula is negative b plus or minus the square root of b squared minus 4ac divided by 2a. Again, you don't have to have it memorized. You can go back and look at that somewhere or look it up on the internet too. It tells you that the solutions are negative 4 and negative 5. We need to prove it. So we're going to plug in these numbers, and this is just a way for you to practice doing this to make sure you're doing it correctly. So 9 squared minus 4 times 1 times 20. Remember the coefficient of x squared here is 1 divided by 2 times 1. That order of operations is really important here. So this is negative 9 plus or minus the square root of 9 squared is 81 minus 4 times 1 times 20. It's going to remain negative because it's a negative 4 times a positive 1 and a positive 20. So minus 80 all over 2 times 1 is 2. So now we have negative 9 plus or minus the square root of 1, which is just 1 divided by 2. So negative 9 plus 1 is negative 8 over 2, which equals negative 4. That's one of our answers. Or negative 9 minus 1 over 2 is negative 10 over 2, which is negative 5. And so there we have proved that these are the answers. B and C also give you the answers, and you are just proving that by doing the quadratic equation. So I'm going to ask that you do those two on your own. If you need help or you get stuck or something's not making sense, look at your signs very carefully. And, of course, you can always text me to ask for help. Select all the equations that are equivalent to 81x squared plus 180x minus 200 equals 100. So for this, I'm looking at the equations that are the same as the one I see here. So I can modify this one to subtract 100 from both sides so that I make this equal to 0, in which case this becomes 81x squared plus 180x minus 300 equals 0. So it is not A, because they did that here, but they got minus 100, and that would be if they added 100 to both sides. But we couldn't do that because we would need to subtract to make this 0. Another way to think of this would be, in this case, if they swapped the 100 and the 200, but again, that would mean that this 100 is negative, so that is also not the case. This one says that we could have this be plus 100 and equals 400 here. So if we were to add 100 to, well, let's see, if we were to subtract 400 from both sides to make this 0, we would get negative 300 here equals 0, which is this. So this looks good. It's just a little strange, right? Because they rewrote it in a very different way. You can also think about it if I were to subtract 100 from both sides, I would get 300 on this side. And if I were to add 200 on both sides, I would get 300. So C looks pretty good. Let's see about D. So D, in order to see if this matches, you need to rewrite it and expand this out. And so we want to see if this equals the one above it. So that's 81x squared plus 90x plus 90x plus 100 equals 400. So that is going to look like, yeah, that'll be the same as the one above it because this will be 180x. That means, though, then that E can't be correct because it has it equal to 0, and that does not equal the same value we get when it equals 0. The last one, too, says equal to 10. If this one is correct, then this one cannot be. All right, number 6 says identify the values of A, B, and C. Oh, I'm sorry. I think this was actually supposed to be a part of that one, but identify the values of A, B, and C that you would use to substitute in the quadratic formula to solve these equations. So again, A equals 1, B equals 9, C equals 18. That's all you're doing here. C, you have to be careful because they wrote it backwards. So you need to rewrite this as 5x squared minus x plus 81 equals 0. Remember, the sign in front of the number is the sign that goes with that number. So if there's no sign, it's positive, right? There's nothing in front of 81, that's a positive 81. Same thing here. They did not fully rewrite this, so you would need to subtract 1/3. So this would be 4/5 x squared plus 3x minus 1/3 equals 0. This one would be x squared minus 121 equals 0, which means there's no middle term. That means that b is 0. Okay? And then here, again, we can subtract 42 from both sides and rewrite this to be 14x squared plus 7x minus 42 equals 0. So you can then find A, B, and C for each one of those. For number 7 is a review of absolute value. And so on the same coordinate plane, sketch a graph of each function. For this one, I'm going to go ahead and sketch my normal graph first. So my normal graph would look like this, right, at 0, 0. Just to help me figure this out. So when it's adding 6 on the inside, that actually means that we're moving to the left 6 units. And so my new graph would be as such. If I'm adding 9 outside of the modulus bars, I'm moving up 9 and then sketching my graph as such. All right, so this one is v of x, and this one is z of x. Now, You can test this again by if I plug in negative 6 plus 6 equals 0. So that works. The point here is 0, comma 9, right? And so if I were to plug in 0 plus 9, that does in fact equal 9. So I know it works out. All right, that's it for your homework tonight. Again, if you have any questions or you need help with anything, please feel free to reach out to me. Your code word for today is going to be jabber. Jabber is your code word for today. All right, happy homeworking, and I'll see you tomorrow.